Okay, this is the in-class review from Monday for the Unit 3 test on triangles. Number one is asking on what are the 5 postulates that prove 2 triangles are congruent? So we've talked about 5 different postulates that allow us to conclude that triangles are congruent. Those postulates are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Okay, so if we have 3 pairs of corresponding sides that are congruent, then we know the triangles are congruent. If we have 2 sides and the included angle, so the angle in between them, okay, then we have side, angle, side. If we have angle, side, angle, so that's 2 angles. So if we have triangles A, B, C, and D, E, F, okay, side, side, side would look like this. Okay, we have 3 pairs of corresponding sides that are congruent, therefore the triangles are congruent. Side, angle, side, we have 2 sides that are congruent and the included angle. So the angle that's between, right? So we have side, angle, side. Angle, side, angle. We have 2 angles in the included side. So angle, side, angle, 2 angles in the included side. The included side, again, is the side between the 2 angles. Okay, and then angle, angle, side is with a non-included side. So it looks something like this, angle, angle, side. Okay, and then hypotenuse leg was when you had right triangles. So we have right angles, and we have hypotenuses that are congruent, and then a pair of legs that's congruent. So again, the hypotenuse is the side that is opposite the right angle, and then the legs, these are going to be our legs. Each right triangle has 2 legs and a hypotenuse, so we need the hypotenuses to be congruent and then the legs. So if we have all that, then we can say the triangles are congruent. Okay, the 2 postulates we do not have are angle, 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 and side, side, angle. Okay, if you get one of those combinations, we cannot use those to prove that triangles are congruent. Number 2, if 2 sides of a triangle are 15 centimeters and 23 centimeters, what is the range of possible lengths of the third side? Explain your answer. So by the Triangle Inequality theorem, we know that 2 sides of a triangle have to be longer than the third side. So the best way and probably the simplest way to go about this is we want to add and subtract these 2 numbers together. Okay, so we know 15 plus 23 is going to equal 38. We know the absolute value of the difference, so 23 minus 15 is going to be 8. Okay, if you did 15 minus 23, you'd have to take the absolute value. So it's going to be a positive number, right? Because you can't have any negative side length for a triangle. Okay, we know x has to be less than the larger number and greater than the smaller number, so x has to be between those 2 numbers. So you add them together and you subtract them, and x has to be between those 2 numbers. But the question is why? So explain your answer. Why does x have to be between those 2 numbers? Okay, because finding this is easy. You add them up, it's got to be less than that number. You subtract them, it's got to be greater than that number. The answer is explain your answer. So I don't care if you explain it in words or if you explain it with mathematical reasoning. So if you do it with math, we're going to use the equations from the Triangle Inequality theorem. Okay, so we know 2 sides have to be greater than the third side. So the 3 sides of our triangle, right? If we call the last one x, we can have 15, 23, and x. So 15 plus 23 has to be greater than x. Okay. Right, 15 plus x has to be greater than 23, and 23 plus x has to be greater than 15. Okay. Here, if we solve these inequalities, here we get 38 is greater than x. Okay, the second one, if we subtract 15 from both sides, we're going to get x is greater than 8. And here we subtract 23 from both sides. We get x is greater than negative 8. So we can rewrite this as x is less than 38. We're just flipping it around. We're not changing any of the math, right? This is saying 38 is bigger than x. We're just going to rewrite it as x is less than 38. Same thing, same meaning. That is where we get this. Okay. Then here we have x is greater than 8 and greater than negative 8. Well, x has to be greater than both 8 and negative 8. So that means x is going to have to be greater than the bigger number, which is 8. Because if we tried 4, right, 4 wouldn't work. We can't make a triangle with 4. Right? 15 plus 4 is not greater than 23. Okay, 19, right? So we can't be between negative 8 and 8. It has to be greater than negative 8. And all numbers that are greater than 8 are going to be greater than negative 8. Right? Every single number greater than 8 is going to be greater than negative 8. Right? But not every number greater than 8 is also going to be greater than negative 8. So we got to pick the top one here. X is greater than 8. Right? Because the numbers in between won't work. It has to satisfy both conditions. It has to be greater than negative 8 and greater than 8. Okay, which numbers are greater than both 8 and negative 8? Well, it's going to be the numbers that are greater than 8. So that's why x has to be greater than 8. So between 8 and 38. Okay. Right, number 3. Find y. So first thing we notice is we have an exterior angle. So we can use the exterior angle theorem. We don't have to use the exterior angle theorem, but they give us an exterior angle. Probably simple if we use it. Okay, the exterior angle theorem tells us our exterior angle is going to equal the measure of the two remote interior angles added together. So the measure of our exterior angle is 146. So our exterior angle is going to add up to the measure of the two remote interior angles, the opposite interior angles added together. So that's 5y plus 3 plus 4y plus 8. Okay, we combine our 5y with our 4y, we get 9y. Combine our 3 with our 8, we get 11. Okay, subtract 11. 135 equals 9y divided by 9. Y is going to equal 15. Right, 9 times 11 is 99. 9 times 4 is 36. 99 plus 36 is 135. So 11 plus 4 is 15. The other way we could have done this problem is we notice these are a linear pair. So 180 minus 146 is going to give us 34. And then we could have done 34 plus 4y plus 8 plus 5y plus 3 equals 180. Combine like terms and solve for y, and we should get 15 that way as well. But the exterior angle theorem is simpler, faster. That's what they intend for you to use when they write this problem. Number 4. If y equals 180 minus 2x, find the value of z. Okay, first thing we notice is we have some isosceles triangles. So if this angle is 50, this angle is also going to be 50. Okay, and then we know that x plus 50 is going to equal 180. So x plus 100 is going to equal 180. Minus 100 from both sides, x is going to be 80. We notice we have an equation, y equals 180 minus 2x. Well, we have x, it's 80. So y is going to be 180 minus 2 times 80. Okay, 2 times 80 is 160. So y is going to be 20. We notice we have an isosceles triangle. Okay, so two ways we can approach this, depending on how you look at it or how you think. We can do 180 minus 20 is 160. So we know these two angles have to add up to 160 degrees. And they have to be the same because it's an isosceles triangle. So these two angles have to be the same. So we can then divide by 2 and we get 80. If you're confused how we got that, you can make these w or some other variable. Okay, w plus w, right? If this angle is w, that angle is also going to be w. W plus 20 is 180. So 2w plus 20 is 180. So minus 20. 2w is going to be 160 divided by 2. W is 80. So either way, we get 80 as our value of these two angles. Okay, we want to find z. Again, we have two options. We can do linear pair. So these are a linear pair. This means they're supplementary. Their measures add up to 180. So we know 180 minus 80 is going to be 100. So we know the measure of angle z is 100. We also could have done the exterior angle theorem. We notice that z is an exterior angle, so it's going to equal the remote two interior angles added together. The two remote interior angles are 20 and 80. 20 plus 80 is going to give us 100. So this one's got a few steps, but none of the steps in and of themselves are complicated. It's just figuring out, we're just doing it piece by piece, doing what you know. Try to figure out what you know, what you can figure out, instead of letting the problem overwhelm you. Right, number 5 wants us to find the measure of all the missing angles from the diagram. Let's start at angle 2. So angle 2 forms a linear pair with this angle that has a measure of 135. So we know 180 minus 135 is going to give us 45. So we know the measure of angle 2 is 45 degrees. Okay. We know this angle is 60, and we know that the three angles, interior angles of a triangle, add up to 180 degrees. So again, depending on what you feel more comfortable with, we can do 180 minus 60 minus 45, which is going to give us 75. Or we can make this a variable, say x, and we can say x plus 45 plus 60 equals 180. X plus 105 equals 180. Minus 105 from both sides, x equals 75. Either way, whatever you're comfortable with, we get 75. Then we have a linear pair, so 180 minus 75 is going to give us 105 degrees. Okay, maybe even easier than that. We didn't really need to figure out that this one was 75. Once we figured out 45, we know that angle 1 is an exterior angle to this triangle. Since it's an exterior angle, it's going to add up to the two remote interior angles added together. So 60 plus 45 is 105. So it makes sense that way as well. So we really didn't even need to solve for 75. Okay. It's hard to read some of these because I wrote over the angles. Vertical angles. So this one's going to be 45. Vertical angles. So this one's going to be 72. Okay, if you're ever stuck, look for vertical angles, look for linear pairs. There's lots of linear pairs and vertical angles on diagrams. Okay, we could have done linear pair here. 180 minus 135 is 45. Okay, we can also have done linear pair here. So 180 minus 72 is going to be 108. And then we could have done 180 minus 108 would give us 72. Okay, measure of angle 3, again, 180 minus 72 minus 45. Right, or if we want to write it out, we can write out the measure of angle 3 plus 45 plus 72 equals 180, because the triangle sum theorem tells us the three interior angles of a triangle add up to 180. All right, 45 and 72 is going to give us 117, right? 77 plus 40, 87, 97, 107, 117. Okay, minus 117 from both sides. The measure of angle 3 is 63. So here we can do linear pair. 180 minus 140 is going to give us 40. Then we have the measure of angle 5 plus 72 plus 40 is going to be 180. 72 and 40 is going to give us 112. Minus 112. Measure of angle 5 is going to be 68 degrees. We also could have used the exterior angle theorem, right? 140 was going to equal 72 plus the measure of angle 5. Minus 72, 68 equals the measure of angle 5. So we could have done the triangle exterior angle theorem for triangles, as well as doing linear pair to find 40, and then doing the triangle sum theorem. That's number 5. Let's go down to 6. So we can't get them both on the same page. Okay, 6 is asking what additional information is needed to prove the triangle is congruent using the angle side congruence theorem. It's basically our angle side postulate. Okay, so we have an angle on the side. Okay. So we have two A's and an S. It means we need two angles on the side. So we only have two choices. If we put this angle, if we use these angles OAL, or whatever that one's supposed, I'm not going to cut off. I'm not sure what the name is. B maybe? OMN? I'm not sure. I think it's probably B. We would have angle, side, angle, right? So we don't want the side to be included. We want the side to be non-included. So we want two angles on the non-included side. So we have to do angle O is congruent to angle M. Then we have angle side. So this question is asking us what, right? We only are given two pieces of information. We need to find a third piece of information that allows us to use the angle side postulate. What would they need to give us in order for us to use the angle side postulate? They would need to give us angle O is congruent to angle M. We need that second angle so that we have two angles and a non-included side. But we can't choose these angles because then the side would be included, so it would be angle side angle, which would tell us the triangles are congruent, but it would not help us prove using angle side. So angle O has got to be congruent to angle. Number 7, can we use the angle side postulate to prove these two triangles are congruent? So we have a side, and we have an angle. So we have all the necessary pieces, but are they in the right order that allows us to use this theorem, right? The side angle side postulate says we need two pair of congruent sides, two corresponding sides that are congruent, and an included angle. The included angle is the angle that is between them. Okay, so if we look here, we have side angle. If we go in order, the angle is not included. It's not between the two sides, so we cannot use the side angle postulate. So really, right now, we don't even know. Not only can we not use the side angle side postulate, we don't know that these two triangles are congruent because we don't have enough information to use any of our postulates. So the first question is no. Okay, the second question asks, if no, what information would you need in order to use side angle side to prove these triangles congruent? Well, we need the included angle. Okay. We need the angle between the two sides, which is going to be angle H and angle S. So we would need angle H to be congruent to angle S. Now we have side angle side. And since we have side angle side, we know our triangles are going to be congruent. So if FH and GH are those same lengths and angle H is the angle it is, there's no possible side GF we could put on there that makes these two triangles different. Right? If we have two sides that are the same and the included angle is the same, there's no way we can make a different shaped triangle. That triangle is going to have to be shaped they have to be shaped like each other, so they're going to be congruent because they're going to be the same size and shape. Okay. So angle H would have to be congruent to angle S because side angle side. Number 8, we have reflexive. So we know these AC is congruent to AC by the reflexive property. So we have side so far. We need an angle. Again, we're looking at side angle side. They want us to see what additional information we need to use side angle side. So we need the included angle, okay, which means the angle in between. But if we pick this angle, we'd have angle side side. If we pick this angle, we'd have angle side side. Okay. So for side angle side, we need the included angle. We need the angle in between. So we need the angle BCA to be congruent to angle DCA. Okay, the included angle, this angle in between the two sides. Side, angle, side. Side, angle, side. Okay. What additional information will allow you to prove these triangles are congruent by the Hypotenuse Leg Theorem? So to use hypotenuse leg, we need 1, right triangles. We need right triangles. 2, we need hypotenuses to be congruent. 3, we need a pair of legs to be congruent. Okay, we need right triangles, hypotenuses to be congruent, and legs to be congruent. And again, to recap a right triangle, okay, we have a right angle. The side opposite the right angle is the hypotenuse. Okay, the other two sides are the legs. Okay, so on this triangle, we have a leg, a leg, a leg, and another leg. Well, for this triangle, we have 2 legs and a hypotenuse. For this triangle, we have 2 legs and a hypotenuse. So in order to prove these triangles congruent, what additional information do we need? So let's see what we have. We have right triangles, yes. We have hypotenuses that are congruent. Yes, AB is congruent to DE. Okay, so yes. Do we have a pair of legs? Not indicated on the diagram yet. So what additional information do we need? Well, we need a pair of legs to be congruent. So we can say AC needs to be congruent to EC. We could say AC needs to be congruent to DC. We could say BC needs to be congruent to DC, or BC needs to be congruent to CE. So as long as you have a pair of legs, one one leg from one triangle congruent to the leg of the other triangle, then we can use hypotenuse leg because we now have right triangles, hypotenuses that are congruent, and a pair of legs that are congruent. You could also say something like C is the midpoint of AE, or C is the midpoint of DB, or DB bisects AE, or something like that. AE bisects DB. Okay. Anything that would indicate that we have congruent legs. Number 9, what additional information is needed to prove the triangles are congruent by the side angle side postulate? So we got a little cut off. I assume this is A. Okay. Well, again, we have reflexive property, so we can always use it. AC is congruent to AC. So now we have a side and an angle. Question wants us to prove them congruent by side angle side, or it's asking us what additional information is needed to prove the triangle is congruent by side angle side. So we're going to need another side. We have one side, one angle. We need another side. Our options are going to be BC is congruent to CD, or AB is congruent to AD. If we use BC and CD, then we have side angle. So if we're going to use side angle side, we need the included angle. So it's going to have to be AB is congruent to AD. AB is congruent to A. Okay, now we have side angle side angle side. The included angle. This is the angle between them, right? It's the angle that each side forms a side, right? Remember, an angle is a vertex and two sides. So an included angle is going to be the angle that has the two sides that are the congruent pieces. Okay. We want to go side, angle, side. Side, angle, side. Side, angle, side. Number 11 says in triangle HFD, so let's draw a triangle HFD. What angle is the included angle between DH? So here's DH. I'll put a dash here. And DF. Well, if we draw it, it becomes clear that it's going to be angle B. Okay, if you don't draw it and you stare at the problem, it might be a little more difficult to figure it out. So you see I have a triangle HFD, draw a triangle HFD. Okay. Again, included angle is the one that's in between. Right? Again, angle D has a vertex, point D, and then it has two sides, DF, if I draw it this way. Okay, D, F, and H, right? So the sides, side, angle, side. It's all part of like one angle. Side, angle, side. That was for the last one. This one is just saying it's the included angle, right? The side angle side is the postulate that has the included angle. The angle that's between the two sides. Okay. In triangle OMR, what is the included side between angle M and angle R? So again, it's probably difficult to look at and determine. So let's draw it. Makes the problem much easier. O, M, R. Here's angle R. Here's angle M. What side's between those two angles? M, R. Right here, M, R. Right, the postulate that uses the included side is the angle side angle postulate. Angle, side, angle. right? Angle side angle uses the included side. Angle side uses one of the non-included sides. So 13 through, I believe, 16. We're going to try and figure out which postulate we should use to prove triangle. Or, yep, 13, 14, 15, 16. Which postulate or theorem, if any, could you use to prove the two triangles congruent? If there's not enough information to prove the triangles congruent, right? Not enough information. 13, we notice we have reflexive property. And so we have side, side. Right? We don't have a third piece of information. So in this problem, there's going to not be enough information. We need 3 corresponding parts to be congruent. And we don't have 3 parts. We only have 2. We can't assume right angles unless they tell us. We can't assume these are parallel, so we can't assume alternate interior angles. So we just have to say there's not enough information. Number 14, we know right angles are congruent. We have a congruent side. So right now we have one angle and one side. But there does not seem to be anything else we can show that is congruent. So we can also check out the hypotenuse leg theorem. Okay, to get a hypotenuse leg, we still need 3 things. We need right triangles, so that means right angles. We need the definition of a right triangle is a triangle with a right angle, so we need right angles. We have right angles, so that's good. We have a side that's congruent. This is our hypotenuse, right? The hypotenuse is opposite the right angle. So here's our hypotenuses. Okay. So we need right angles because we need right triangles. We need hypotenuses to be congruent, which they are. Then we also need a pair of legs to be congruent, but there's nothing here that's going to indicate a pair of legs that's congruent. 15, we notice we have vertical angles, so let's put them in. And now we have how many parts? How many corresponding parts that are congruent? Well, we have 3 corresponding parts that are congruent, so we can try to use one of our postulates. Okay, is this a side or an angle? This is a side. Is this a side or an angle? This is an angle. Is this a side or angle? This is a side. So side, angle, side. 2 sides and an included angle are congruent, right? So 2 corresponding sides are congruent. And then the included angle, the angle between the 2 sides is congruent. So side, angle, side. Okay. How many corresponding parts do we have that are congruent in number 16? 3. We have angles here and here. We have angles down here. And we have sides. So since we have 3 corresponding parts that are congruent, let's see if we can use one of our postulates. So this is an angle, this is an angle, and this is a side. Okay, we have 2 angles, 2 corresponding sets of angles that are congruent, and a non-included side. So angle, angle, side. 2 angles that are congruent and a non-included side. Okay, 19, we're going to name the postulate that proves the triangles congruent. Okay, so we have 6 of them. So let's name the postulate that shows that the triangles are congruent. The first box here, we have 2 triangles, 3 corresponding parts that are congruent. We have an angle, a side, and an angle. So again, we go in order. This is going to be angle, side, angle. 2 angles, right? This angle and this angle are congruent. This angle and this angle are congruent. And then we have an included side, a side between the 2 angles. So we have angle, side, angle. Okay. Next one, we notice a shared side. So we can put that in. How many corresponding parts do we have that are congruent? We have 3. We have angles here and here. Cover up one of the triangles. Okay. We have angle, angle, side. Okay, two angles and the non-included side. Since it's two angles and the non-included side, we have angle, angle, side. If you were going in order and you said side, angle, angle, you should be able to notice that that's the other way, angle, angle, side. Flip it around and make sure you put angle, angle, side, right? Because angle, angle, side is defined as two angles and the non-included side. So here we have two angles and a non-included side, but we want you to write it as angle, angle, side. Two angles and the non-included side. Okay. Here's the last four of those then. Third one, we have vertical angles. Okay, so we can put our vertical angles in. Three pairs of corresponding parts that are congruent. We have an angle, right? These angles are congruent. These angles are congruent, and then these sides are congruent. So three corresponding parts that are congruent. Is this an angle or a side? This is an angle or a side, that's a side, angle or side, that is an angle. So it's going to be angle, side, angle. All right, two angles, two corresponding angles that are congruent, and the included side. So this side is between the two angles. This side is between the two angles, so it's the included side. So it's angle, side, angle. Next one we notice we have shared side. Okay. I think what they're going for on this one is definition of congruent triangles. So at this point though, we could do side, angle, side. We could do angle, angle, side, angle, side here. Okay, but I think what they're going for is definition of congruent triangles. So we can use the third angle theorem, which tells us if we know two angles, two pairs of angles are congruent, two corresponding angles are congruent, then the third corresponding angle is going to be congruent. So then we can conclude that those are congruent, which will then allow us to say that these two triangles are congruent by the definition congruent triangles. Right, again, the definition of congruent triangle says that if all three corresponding sides are congruent and all three corresponding angles are congruent, then the triangles are congruent. But you don't have to use definition of congruent triangles. Again, we could have just not done anything and done side, angle, side, or angle, side, angle, or angle, angle, side. Okay, or we can do reflexive. Now we have side, side, side. Okay, we have right angles, so we have right triangles. We have a pair of legs that are congruent, and we have hypotenuse that's congruent. So we could have done HL. So any of those five postulates would have worked on this one. Or you could say it's they're congruent by the definition of congruent triangles because all six corresponding parts are congruent. Okay, last two. This one's, we should see right away, we have side, side, side. Okay. Three pairs of sides, three pairs of corresponding sides are congruent. 1, 2, 3. So by the side, side, side postulate, if we have three corresponding sides that are congruent, then the triangles are congruent. Okay, the last one here. We have a shared side. Okay. So again, if that's a right angle, we know this is a right angle, and we know by the right angle theorem, all right angles are congruent. Okay. But we would have side, side, angle, which is not one of our postulates, right? Angle, 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 and side, side, angle are not postulates that we can use to prove triangles congruent. We only have side, 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 angle, side, angle, side, angle, or angle, angle, side. Okay, so we have to rethink it. Since we have a right angle, we should try hypotenuse leg, so we still have a reflexive side. Okay. So the hypotenuses we know are going to be congruent. Okay, and then we have a pair of legs that's congruent. So we're going to use hypotenuse leg. If you're having trouble seeing this, let's draw it back out. I'm going to draw them split up. Okay, the reflexive property lets us know these sides are congruent. So we know here it's congruent to there. We're given that those are congruent, and then we know these are right angles. So if we go through our checklist for HL, first step, we need to make sure they are right triangles. So we have a right angle, therefore they are right triangles. A right triangle is a triangle with a right angle. So that's step one on our checklist. We have right angles, we have right triangles. Step two, do we have hypotenuses that are congruent? Again, the hypotenuse is opposite the right angle. So yes, we do have hypotenuses congruent. Step three, do we have a pair of legs that's congruent? And yes, here we have a pair of legs that are congruent. Right? Again, one more time. Here's the hypotenuse of a right triangle. These are the legs of a right triangle. So opposite the right angle is the hypotenuse, and the other two that are adjacent to the right angle, the two sides that are adjacent to the right angle are the legs. So that one is hypotenuse leg. What's more we got? Next problem. It's telling us triangle ABC is congruent to triangle KJH. Okay. So we know that AB is congruent to KJ. We know that BC is congruent to JH. BC is congruent to JH. And we know that AC is congruent to KH. Okay. So AB is congruent to KJ. So AB is equal to KJ. AB is 5y minus 12. KJ is 113. We add 12 to both sides. 5y is going to be equal to 125 divided by 5. Y is going to be 25. Okay. 5 goes into 100 20 times. It goes into 25 5 times. 20 plus 5 is 25. Okay. We also know that BC is going to be congruent to JH. So therefore, BC is going to be equal to JH, right? The length of BC is going to be equal to the length of JH. So we know 4x minus 3 is going to equal 9. Add 3 to both sides. 4x is going to be 12 divided by 4. X is going to be 3. Okay. Again, as long as you put your marks on there and write the information you know down, that should be a fairly simple problem. Okay? Don't just stare at blankly going, I don't know. Right? Look at the information you have, put it in there. Okay, 20. 20. Okay. If triangle ABC is congruent to triangle DEF, let's draw them in. Triangle ABC, triangle DEF. Right? And those triangles are congruent. So AB is congruent to DE. BC is congruent to EF. And then AC is congruent to DF. Okay, we also know angle A is congruent to angle D, angle B is congruent to angle E, and angle F is congruent to angle C. The measure of angle D is 4x plus 1. The measure of angle B is 3x plus 4. And the measure of angle F is 3x plus 6. Okay, find x. Sorry, the measure of angle F is 3x plus 6. Okay. Well, since we know the triangles are congruent, we know angle B is congruent to angle E. Okay. So we know the measure of angle B is equal to the measure of angle E. Right, so the measure of angle B is 3x plus 4. The measure of angle E is going to be 3x plus 4. Okay, we now have expressions for the three measures of the angles in the second triangle. And we know the three angles of a triangle add up to 180. So we know 3x plus 4 plus 4x plus 1 plus 3x plus 6 is going to be 180. Combine like terms. 3, 4, and 3 is 10x. 4, 1, and 6 is going to be 11. Do we have that right? Yeah? I think I screwed up in making it a basic problem. Okay, minus 11. 10x is going to be, if we go, well, I'll write it down here. 10x is going to be equal to 169. Divide by 10. X is going to be 169 over 10. Thought I checked all my numbers to make sure they worked out good, but I guess I didn't. We did it right, though. B is that, yeah. And then D and F. 4 plus 3, and 3 is 10. Yeah. Well, that's fine. Fractions are good. They're just numbers like every other number. Okay, so that's 20. Okay. 21 is very similar. Okay. So again, we should draw the triangles. This is high enough to see, yep. Triangle A, B, C, and triangle D, E, F. And D, E, F. So just like the last one, they're congruent, so we can put all of our marks in to symbolize congruence. Okay. We know AC is x plus 3. We know DF is 4x minus 3. And we know angle BCA is 6x plus 30. We want to find the measure of angle EFD. Okay, well, we know angle BCA is congruent to angle EFD. So we know the measure of angle BCA. It's going to equal the measure of angle EFD. So we know EFD is going to be 6x plus 30. Okay, so we know the measure of angle EFD is 6x plus 30. But we don't know what x is. Luckily, we have another pair of congruent sides where we can find x. So we know AC is congruent to DF. So AC is going to equal DF. Okay, so x plus 3 is going to equal 4x minus 3. Minus x, 3 is going to equal 3x minus 3. Add 3 to both sides. Okay, we have, I'm going to do it over here. We have 6 equals 3x. Divide by 3. X is going to be 2. So substitute that in. 6 times 2 plus 30. 6 times 2 is 12 plus 30. That's going to give us 42 degrees. So that's the measure of angle EFD. I'm tired. I'm writing sloppy because I'm tired. Well, sloppier than usual. And this pen's dying. Okay, so the measure of angle EFD is 42. Okay. So again, draw it. Once you draw it, the problem becomes much simpler because you can visualize what's going on. If you're trying to do it all in your head without drawing it, it's much more difficult to visualize without actually having a drawing in front of you. You guys make problems much harder than they need to be by not drawing them. Okay, 2 more. Find the range of values for the third side of the triangle. So again, we have 2 sides, which is 100 and 450. I'm just going to call this x. I know there's an x, but just to make it simple, I'm going to call it x. So we add the 2 numbers, right? 450 plus 100, and then we subtract them. 450 minus 100. So that's going to be 550 and 350. So we know x has to be between these 2 numbers. So it has to be less than 550, greater than 350. Okay, the question is why? Though, is that the case? Well, it's the case because the 2 sides have to be longer than the third side. So 450 plus 100 has to be greater than x, which means 550 is greater than x, which can be rewritten as x is less than 550. X is less than 500. All I did is flip the whole thing around. Okay, x is less than 550. Okay, we also know that 100 plus x has to be greater than 450. These 2 sides have to be longer than the third side. Okay, subtract 100. X is greater than 350. Okay, then we also know that 450 plus x has to be greater than 100. Minus 450, x is greater than negative 350. So in order to be greater than negative 350 and greater than 350, we can just include the numbers that are greater than 350. Because if it's not greater than 350, it's not going to fit this expression, even though it might fit this one. So greater than 350, less than 500. Okay, I'm not sure how much room I have in here to do the proof. But let's try it. Yeah, it should have. Well, I'll write small. Hopefully you guys will be able to read it. You can zoom in or something. Or I can try to zoom in. Probably better. I can't see the whole thing though. Try to do it in this gap up here. Okay. So we have steps, justifications. First thing we do in our process is write the givens. So we have 2 givens. So AC bisects angle BCD. And then 2 is AC bisects angle BAD. Okay, and those are given. We also have a shared side, right? So step 1, write the givens. Check. We have 2 givens, we wrote them. Step 2, look for shared sides of vertical angles. Here we have a shared side. So we know AC is congruent to AC by the reflexive property of congruence. Property of congruence. Okay. So step 1, write the givens. Step 2, look for shared sides or vertical angles. Step 3, use the given. So let's use our first given. AC bisects angle BCD. So here's angle BCD. We're bisecting. AC is bisecting angle BCD. Okay, it's splitting this angle in half. So it's splitting angle BCD into 2 congruent angles. The definition of an angle bisector is that it bisects the angle. It splits the angle into 2 congruent pieces. So now angle BCA is going to be congruent to angle DCA. That is the definition of an angle bisector. So that's our first given we've used. Here's our second given. Okay. So we're going to bisect now. AC is bisecting angle BAD. So we're bisecting this angle right here. We're splitting this angle in half into two congruent pieces. So those pieces are angle BAC and angle BAC. That's again definition, angle bisector, right? An angle bisector is a bisector that splits an angle in half. So we're splitting angle BAD in half to get these two angles congruent, right? It bisects BCD, so it splits BCD in half to get these two angles congruent. Okay, now we've written our givens. We've looked for shared sides of vertical angles. We used our givens, so we've used our givens. We now have three corresponding parts that are congruent, two angles and a side. So we know it's either going to be angle, or angle, side. Let's look at our triangle. Cover one of the triangles up. This is a side or an angle. That's an angle. That's a side. That's an angle. So by the angle side angle postulate, we can prove that triangle ACD is congruent to triangle ACB. So that's the in-class review from Monday, December 3rd.